All right, so 2.4 is on transformations in the planes, and there is a whole unit on transformations later on in the course, but this is just some basic transformation information that we're going to cover today. So, like the bare minimum generic transformations, and then later on we'll take it a step further. So, the I can statement for this section, I can analyze figures and identify the types of transformations. All right, so there are 3 types of transformations that we will focus on today. And these 3 collectively are part of what we call rigid transformations. So we are going to add that. Also, there is, you need to be sure to keep track of the names. At least I spit out the wrong thing half the time I'm trying to talk about this. So a transformation is something changing. A type of transformation that we deal with is a translation, which is the one listed in the middle. So if I ever spit out the wrong one, just let me know and I'll make sure that I'm saying the right thing. All right, so we have a reflection. A reflection is just what it sounds like. This is what we call our pre-image, and this is our image, what comes after it's transformed, in this case reflected. So let's label that. So this is our pre-image and our image. The way we can tell is our pre-image, it has the letters by themselves, and the image has the letters with an apostrophe, and the way we read those are prime. So this would be A prime, B prime, C prime. Okay, and then just some notation you need to see is that triangle ABC is transformed to triangle A prime, B prime, C prime. So think of a reflection like looking in a mirror. What you see is directly the same. So like if you were to stand in front of somebody and mirror them, you put your right hand up to match you, they would be putting their left hand up, but it's still that same side. So it's just basically being flipped over this line. A reflection is always over some line. All right, next up we have a transformation. A transformation is just a slide. So if you wanted to write words here, let's go back here. So a reflection is a flip. A translation is a slide or a shift. Okay. And again, the way you tell which is your pre-image and your image is which one has the apostrophes. Same thing, triangle ABC becomes triangle A prime, B prime, C prime. And then a rotation, think of like a doorknob, it twists or turns. So twist or turn. Okay, and you always rotate about a point. So in this case, here's the point that we're rotating about. In this section of notes, the point that we are going to be rotating about is the origin. When we get into the actual transformations chapter later on in the course, that's when we'll look at rotating around points that are not the origin. So again, triangle ABC is rotated to triangle A prime, B prime, C prime. I also want to go back and touch base on reflection real quick. So like I said, these are the generic transformations. So what made this one the rotation generic is that we're rotating around the origin. What we're doing in this section, the generic version of a reflection, is reflecting across vertical or horizontal lines. I think this chapter focuses on just the X and Y axis, but it could be other vertical and horizontal lines. I cannot remember for sure, but either way, those are easier to do than what we do later on in the transformation unit. All right, in example 1, it says identify the type of rigid motion. So remember, rigid motion is any of these three. Okay, what type of rigid motion is shown in the photo? Is it a reflection, translation, or a rotation? This would be a reflection, and the line it's reflecting over is right here. Let's use a different color. Okay. And over here it says the game of checkers. Players move their pieces on the diagonal. Identify the type of rigid motion shown as a reflection, translation, or rotation. So remember, it says that they move their pieces diagonally. It's being shifted, okay, like this way and this way. So this would be a translation. All right, example 2, it says identify the type of rigid motion shown in the photo as a reflection, translation, or a rotation. So we can tell that. Also, we need to define that blue is the image. So if you want to give a little key, so this is the pre-image, and green is the image. All right, so here we have a diamond that looks exactly the same right here. Okay? This is going to be the orientation's the same, the size is the same. It could be, no, it can't be anything else. Anyways, so the way to tell what it is, in this case it's a translation, is that you can draw a line from from each point to its corresponding point on the image, and then all of those lines should be parallel. They have the same slope. So this is a translation. All right, and the reason it is a translation is that each point can be connected by lines that are the same length. All right, so part B, we have what appears to be a reflection. And the reason this is a reflection is because each point and its image are equidistant from each other. All right, and then the last one, part C, this is a rotation, and this one's a little bit easier to tell because the triangle kind of, turns this way. So this is a rotation, and the way you tell is that each vertex and its image are equidistant to the origin. And you can see that demonstrated with these lines and the tick marks showing that they're the same length. So this point and this point, or this one to the origin and this one to the origin, they're marked with 2 tick marks. This one and this one are marked with 1 tick mark, indicating that they are indeed the same length. All right, so on the back here, this is where we're going to figure out how to find the coordinates, or how to take something and rotate it or translate it, or find the reflection. So on the front side, we were just identifying if it had been one of the following. So now we're figuring out how to actually do that. So it says to reflect a point over the x-axis. So we are focusing on just the axes in this section. So we have the x-axis and the y-axis. So it says to reflect a point over the x-axis, multiply its y-coordinate by -1. So if it's the x-axis, you're multiplying the opposite coordinate by -1, and then vice versa for the y-axis. So you are multiplying the x-coordinate by -1. All right, so if the point that we start with is xy, then to reflect it over the x-axis, it would be x -y. So let's say y was already negative, then it would become positive. You're multiplying it by -1. All right. Same thing goes for the y-axis. So if we start with the point xy, then it would become -xy. All right, let's go ahead and do the rules for all of these first, and then we'll do the examples. Okay, so over here, we're looking at translations. It says to translate a point along the vector AB. So this looks like an ordered pair, but what makes it different is these arrow-looking brackets. Okay, that indicates that it is a vector. So you are going to add A to the x-coordinate and add B to the y-coordinate. So it looks like this. So if we start with the point xy, if it's translated along this vector, it would be the x-coordinate that we started with plus A. And then it would be the y-coordinate that we started with plus B. And that would be our new coordinate. All right. And then lastly, we have rotations. So there are 3 main rotations that we will consider. We have rotating about a point, versus to rotate a point 90 degrees CCW. CCW stands for counterclockwise. If you don't think you'll remember that, make sure to note that somewhere. Okay, so if you're rotating 90 degrees counterclockwise, you're going to multiply the y-coordinate by -1, and then interchange the x and y coordinates. So what that looks like is we start with the point xy, then it would become, so we're negating the y coordinate and interchanging, so flipping the order. So the y value will now be the x value, and it's also negative. And then the x value will be the new y value. All right, to rotate a point 180 degrees counterclockwise, also something to note, when you're rotating 180 degrees, this does not matter, because 180 degrees counterclockwise is the same as 180 degrees clockwise. All right, so anyways, we're going to multiply the x and the y coordinates by -1. So the only thing that changes this is the signs. The order stays, the signs change. So we're going to have -x, -y. And then lastly, we're rotating 270 degrees counterclockwise. We're multiplying the x coordinate by -1 and interchanging the coordinates again. So it's the opposite of what 90 was. Still interchanging, but negating the other coordinate. So we have xy. We're going to flip the order, remember. So y will be the new x value, and x will be the new y value, but the x is also negative. All right, so now that we have this information, let's go through and do examples 3, 4, and 5, and then you can do the last row on your own. Pause it, do those last problems, and then you can check your answers after the fact when you're ready. All right, so example 3, it says triangle ABC has the following coordinates. It says reflect the triangle over the x-axis. So if A starts as 3, 2, and we're reflecting over the x-axis, we are multiplying the opposite coordinate by -1. So reflecting over the x, we're going to multiply the y coordinate by -1. So that means that a prime is 3, -2. All right, b is 2, -2, which means b prime is 2, +2. And c prime, or no, I'm sorry, c is 4, -5, and c prime is 4, 5. All right, for the second part of example 3, we're using the same coordinates but reflecting over the y-axis. So we're still starting with a as 3, 2, but since we're reflecting over the y, you negate the opposite coordinate. So in this case, we're negating the x values. So that means that a prime would be -3, 2. If b is 2, -2, then b prime is -2, -2. And c starts as 4, -5, then c prime is -4, -5. All right, example 4. It gives us the coordinates for this quadrilateral QRST, and it wants us to translate it along the vector 7, 1. So what that's going to look like is, and you might want to plan your spacing properly. So we have Q starts as -8, -2. All right, so that means Q prime is going to be -8 + 7. And in the y value, it's going to be -2 + 1. I'd also like to note that if this vector, say, said -7, 1, then instead of adding 7, we would subtract 7. So just keep that in mind for future problems. All right, so r is -9, -5. R prime would be -9 + 7, -5 + 1. S is -4, -7. So S prime is -4 + 7 and -7 + 1. And lastly, T starts as -4, -2. So T prime is -4 + 7 and -2 + 1. So now what we're going to do is we're just going to simplify those. So the final coordinate for Q prime is going to be -1, -1. The final coordinate for R prime is going to be -2, -4. The final coordinate for S prime, 3, -6. And T prime is 3, -1. All right. Example 5 says the quadrilateral FGHJ has the following vertices. Rotate the image 180 degrees. Notice it does not tell you a direction because remember 180 is the one that the direction doesn't matter because both ways you choose to turn will still end up in the same spot. So F is 2, 1. Then F prime is just those two values negative. So -2, -1. G is 7, 1. G prime is -7, -1. H is 6, -3. So H prime is -6, +3. And J is 1, -3, so J prime is -1, +3. All right, now you are going to try these 3 problems on your own, so pause the video while you work on those and resume once you're ready to check. All right, so for these last 3 problems, the first one says triangle JKL has coordinates as follows. Determine the coordinates of the vertices of the image after a reflection over the x-axis. All right, so J is 2, -8. If we're reflecting over the x-axis, then we're multiplying the y value by -1. So that means J prime would be 2, 8. All right, K is 6, -7. So K prime is 6, 7. Go ahead and laugh. Lastly, we have L, 4, -2. So L prime is 4, 2. All right, the second one, we have quadrilateral ABCD. The vertices are as follows. Translate the image along the vector 5, -3. So instead of rewriting the coordinates like I did up here, to save some space, I'm just going to skip to this step and then we'll simplify it. Okay, because you should obviously know that the points, these are the starting points. All right, so we have A prime is -3 plus 5 and 1 minus 3 because this 3 is negative. All right, then B prime is -5 plus 5 and 3 minus 3. C prime is -2 plus 5 and 5 minus 3, and D prime is -1 plus 5 and 3 minus 3. All right, so A prime is 2, -2. B prime is 0, 0. C prime is 3, 2. And D prime is 4, 0. All right, last column. This one is a rotation. We're rotating 270 degrees. I don't know if I mentioned earlier, but if it does not tell you a direction, so it does matter for this one, it didn't matter for the 180, but if it doesn't tell you a direction, the default direction, so if you want to write this up here, is counterclockwise. All right, so we have JKLM, we're rotating at 270 degrees counterclockwise. So J is 1, 2. If I'm rotating at 270 degrees counterclockwise, what does that rule say? Then we are switching the order and negating the X value, which is the new Y value. Okay, so the Y value of the original is now the X value. The X value of the original is now the Y value, but opposite sign. So J prime is 2, -1. All right, K, 4, 3. So K prime is 3, -4. All right, L is 6, 1. So L prime is 1, -6. And M is 3, 1. So M prime is 1, -3.